Welcome back, everybody, to another explainer. Today, we're bringing some serious clarity to a fundamental piece of science that honestly applies to literally every single step you take. We're going to tackle the fascinating world of motion, specifically looking at the critical difference between distance and displacement. So think about this for a second. When you travel from one place to another, what exactly are you measuring? Like, think about your morning commute. Are you measuring all the winding roads and the random detours? Or are you just measuring how far your office actually is from your house in a straight line? Are you simply tracking every little footstep? Or is there, something more to the story of your movement? It seems like a pretty simple question, right? But the answer completely changes how we understand the physics of our physical world. Okay, let's dive into section 1, distance, the total path. We'll start with something super comfortable and familiar. Distance is simply defined as the total path that you travel. It absolutely doesn't matter how many turns you take, if you zigzag all over the place, or which direction you're moving. It only cares about the actual length of the path itself. Think of it kind of like the odometer in your car, or maybe that step counter on your wrist. It just keeps ticking upwards. Whether you're pacing nervously in a waiting room or running a massive marathon, distance is always a positive number that just tells us how much ground you've actively covered. But here comes the scientific plot twist of our explainer. Section 2, displacement, the straight line. This takes us from the everyday concept of just covering ground to a way more precise way of looking at motion. Displacement is strictly defined as the shortest, straight-line distance between your exact starting point and your final position. And, oh, here is the kicker, it absolutely must include direction. This brilliantly illustrates how displacement cares deeply about your overall change in position. It completely bypasses all your random wandering and simply tells us exactly how far and in what specific compass direction you actually moved from start to finish. Let's see how this plays out in a real-world scenario with Section 3, the circle test. We're going to run a little mental experiment here that perfectly illustrates the totally wild paradox between these two measurements. I want you to imagine waking up, stepping outside your front door, and walking a massive, full circle around your entire neighborhood. You follow this really long, curved path, exerting all this energy, sweating through your shirt, and eventually you return exactly to the spot where you started. So your starting point and your ending point are completely identical. Well, behold the incredible power of zero. In this circular walking scenario, your displacement is exactly zero. Crazy, right? Because remember, displacement only draws a straight line from your start to your finish. If those 2 points are the exact same physical spot, that connecting line has a length of 0. Notice how this completely contrasts the messy reality of the total path against the clean, mathematical reality of having the same start and end point. Your distance is the entire circular path you just walked. Maybe that's, 3 or 4 miles of really hard effort. But your displacement? 0. Despite all that hard work, you technically haven't been displaced from your original position at all. Now that we have that mental model firmly in place, let's unlock the formal terminology in Section 4, scalar versus vector quantities. Knowing this rulebook is really what unlocks the broader world of motion for you. So here's the technical breakdown. Distance is what scientists call a scalar quantity. That just means it only has magnitude, which is really just a fancy scientific word for size or amount. 10 miles, 50 steps, 100 feet, that's all scalar. Displacement, however, is a vector quantity. This means it possesses both magnitude and direction. 10 miles north, 50 steps forward. Think about it like this. If you're hunting for buried treasure, a scalar of 50 paces is completely useless without the vector direction of east. If you don't have the direction, you don't have a vector, and you definitely don't have displacement. Okay, let's bring all of this together. The core takeaways here are delightfully straightforward. Distance simply answers the question, how much did you travel? Displacement answers the question, how far are you from where you started, and in which specific direction? Grasping this really simple but profound difference is your foundation. It makes learning literally everything else about motion, stuff like velocity, acceleration, and momentum, so much easier to visualize. I'll leave you with this final, slightly philosophical thought to ponder as we wrap up today's explainer. If you wake up in your bed, travel all around your bustling city all day long, and end up back asleep in that exact same bed, did you really go anywhere at all? I mean, according to your distance, you had a huge day, but according to your displacement, not so much. I really hope this sparks your curiosity to keep exploring how science defines our reality. Thanks so much for joining me, and keep on learning.